Hi Neet aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்க. எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yes, good afternoon students. Already in first video I explained reaction intermediates, carbocation, carbanion, free radical and carbene. Now we can discuss nitrene. Another intermediate is nitrene. Nitrene intermediate is one of the, it is isoelectronic with nitrene intermediate. Nitrene is isoelectronic with amides. It is similar to amides. Nitrene intermediate is isoelectronic with amides. In nitrene intermediate is in what is the reaction intermediates in Hoffman reaction. In Hoffman reaction, this is the one of the intermediate. Another one is the Curtius reaction. Next to Lawson reaction and Schmidt, Schmidt. Schmidt. These are the reaction. The intermediate is nitrene. One is the Hoffman, Curtius, Lawson and Schmidt. And these are the intermediate. Nitrene is the intermediate. Now I am take N double bond, C double bond O. In the presence of light, what is happening? Here is nitrene. Nitrene is the intermediate, remaining CO is removed. This is the lone pair of electrons. These are the lone pair of electrons. And next one is the RCO, N double bond, N plus double bond, N minus. In this also, in the presence of light, write RCO, N. These are the lone pair of electrons plus N2 is removed. This is the one of the intermediate. Nitrene is the intermediate. And which reaction nitrene is the intermediate? Hoffman reaction, Curtius reaction, Lawson reaction, Schmidt reaction. And nitrene is isoelectronic with amides. Already as last class I explained carbene. And this is the nitrene, Rn double bond, C double bond O in the presence of light to form nitrene. And nitrene after we can explain Ylide is the intermediate. Ylides, phosphorus ylides in Witting reaction, right ma? Ylides also intermediate. Vicinal diionic compounds. Vicinal diionic compounds is called ylides. What is ylides ma? Ylide means vicinal diionic compounds. For example, we can write RC minus, here also X plus. In X place we can write nitrogen, sulfur and phosphorus. In X place, X is equal to, these are the nitrogen, sulfur and phosphorus. Vicinal diionic compound is called ylides. Now triphenyl phosphine, for example I am writing C double bond O, here is phosphorus. I am taking phosphorus. Now it is reacting with aldehyde, ketone, and this bond is shifted like this. This bond is shifted to form, here is phosphorus, here is oxygen. Now here is the bond is formed now this bond is shifted like this and this bond is shifted like this to form, what is the product? Alkene is the product, and PO. In the X place I am writing phosphorus. And this halide reaction with the ketone to form cyclic adduct. After cyclic adduct to form alkene and PO. Next, triphenyl phosphine methylene, triphenyl methylene phosphorus, triphenyl, write down, triphenyl methylene phosphorus halide in Witting reaction. Which is the intermediate in Witting reaction? Triphenyl methylene phosphorus. Triphenyl methylene. This CH2 double bond means methylene, phosphorus halide. This is the one of the another intermediate. In between substrate and product, one intermediate state, that is the halides. Halide means vicinal diionic compounds is called as halides, and we can take phosphorus halide reaction with a ketone and a cyclic adduct is formed. After cyclic adduct to form alkene. Now Witting reagent is the triphenyl methylene phosphorus. Next one is the sigma complex. Another intermediate is the sigma complex. Generally sigma complex is seen in aromatic electrophilic substitution reaction. Where it is observed the sigma complex? Sigma complex is observed in aromatic electrophilic substitution reaction. Now I am taking benzene ring, this is the benzene ring, double bond here is. Now electrophile is there, just electrophile is a plus charge. Now this double bond, pi electrons are abstract this electrophile to form, this is the structure. Here is double bond, here is E, here is plus charge is formed. Why here is plus charge and this bond is shifted to abstract this electrophile? Now simply this bond is shifted to this place. What is happening? Here is double bond, here also double bond. Here is if here is positive charge, now it is coming to this carbon. Now here is electrophile. Now this bond is shifted like this, means this positive charge goes to this carbon. Now another carbon, it will be, this bond is shifted to here and this bond is shifted here. Here is positive charge, here is electrophile. Now we can denote it as electrophile like this. This is the sigma complex. This sigma complex intermediate is the aromatic electrophilic substitution reaction. After removal of proton, here this hydrogen is there na, removal of proton. What is happening? Removal of proton, and this one is the product is electrophile substitution reaction. Friedel-Crafts alkylation, Friedel-Crafts acylation and nitration. Next to sulfonation reactions are, what is the intermediate, students? Sigma complex, aromatic electrophilic substitution reaction goes through the sigma complex. In aromatic electrophilic substitution reaction, first one is the formation of electrophile, and after a formation of reaction intermediate, formation of sigma complex means carbocation. After removal of proton, here is what is happening? Removal of proton, removal of H plus minus H plus, removal of proton to form electrophilic substitution. This is the mechanism of the sigma complex. Okay now, this sigma complex how to form? This is the benzene ring, this is the electrophile. This pi electrons are easily delocalized, not localized. Delocalized means rotation. It will be abstract this electrophile and now this bond is shifted to this one. This bond means here is positive charge, and this bond is shifted here means here positive charge, and this bond is shifted means positive charge is this carbon. Because this one is shifted, this positive charge on this carbon. This is the sigma complex. Next one is the another important intermediate. We are discussing reaction intermediates. What are the reaction intermediate? Carbocation, carbanion, free radicals. Another one is the carbene, nitrene, ylides, and next sigma complex. The last one is benzene intermediate. Please write the benzene structure. Benzene intermediate. Benzene intermediate. This is the benzene intermediate. Benzene intermediate. How to form the benzene intermediate? Benzene intermediate. First I am taking benzene, chlorobenzene. This is the chlorobenzene. Chlorobenzene. In the presence of sodamide, NaNH2. NaNH2 is the base. To abstract the proton here. Now here is minus charge is formed. Here is minus charge. Here is chlorine is present. Here is Na plus, NH2 minus. Here is Na plus is present. Na plus and Cl minus can be removed as a NaCl. Now this bond is shifted like this. Benzene intermediate is formed. Benzene intermediate. This is the benzene structure. Now benzene treated with liquid ammonia. Treated with liquid ammonia to form aniline. To form aniline. And which one is the intermediate? This is the benzene is the intermediate. Benzene is the intermediate. These are the reaction intermediates in various reactions. One is the carbocation, carbanion. Another one is the free radical, carbene, nitrene, and ylide, sigma complex. Another one is the benzene. These intermediates are isolation is sometime it is possible, sometime the less lifespan is present for intermediates. It is difficult to isolate it, and these are used in various named reactions. And thank you watching my videos, and please subscribe and comment it.